Question 2. Okay, so there's a lot of information up here. So thermal energy is needed to change state of a substance from solid to a liquid. Calculate the thermal energy needed to change the state of 3.5 kilograms of a substance with a specific latent heat of 336,000 joules per kilogram. Use an equation selected from the list of equations on the back of this paper. Okay, so on the back of the paper, I've got the equations, and I'm looking for latent heat. Okay, so there's my equation. Thermal energy equals mass times latent heat. Q equals M times L. Okay, so the first thing I like to see on here is not numbers, I like to see the equation. Okay, and then it's a case of set the mass 3.5 kilograms and the specific latent heat 336,000. Okay, I did find one script where they'd put an extra zero I hadn't counted, so I sometimes use commas just to be able to separate the numbers out so you don't lose your numbers of digits. Okay, so part 2. Give one reason why a change of state from solid to liquid is described as a physical change. Okay, so here you need to state what physical change is. So it's a physical change because it's reversible. Okay, you can put something along the lines of no chemical bonds are broken or created, so when you reverse it, it goes back to its original state. Okay, part B. Okay, kinetic theory here. So it says the kinetic theory describes solids, liquids and gases in terms of particles. The table gives the densities of various substances at room temperature. Okay, so you need to identify that water at room temperature is a liquid, lead is a solid, and air is a gas. Use the kinetic theory to explain, in terms of particles, the difference in densities of lead and air. A lot of people start talking about water. Okay, you need to read the question. Okay, so particles, kinetic theory, how are particles arranged in a solid? So lead is a solid, lead is a solid. In a solid, particles are tightly packed. So have high density. In a gas, in brackets air, particles are very spread out. So have a low density. Okay, most people were successful with that question, that part of the question. Part C. Okay, one of the cyanils has a mass of 2.7 grams and a volume of 0.31 centimeter cubed. Calculate the density. So to calculate, now unfortunately we haven't had a chance to go through this equation yet, but density equals mass divided by volume. Okay, so it's just 2.7 divided by 0.31. Okay, and correctly identified here 8.7 grams per centimeter cubed. Okay, and part D. Okay, again, something we haven't managed to go through in class yet. So this is describe how the movement of particles in a substance changes as the substance is cooled down towards minus 273 degrees centigrade. Now that is absolute zero. The temperature can't go below. So what will happen to particles as you cool them? So the particles will become more compact and vibrate less as they are cooled. At absolute zero, they will be still, or they will stop vibrating.